Today's crystalline silicon solar panels are expensive. Thin-film solar cells are more affordable. They're extremely thin and flexible and can also be used on facades or garden fences. TU Delft is working to improve the yield of these solar cells. The silicon layer of a thin-film solar cell is 100 to 500 times thinner than the silicon layer in current solar cells. How do they work? Light particles, photons, originating in the sun, strike a building with solar cells. The cell consists of several layers. A photon can collide with a silicon atom in the intrinsic silicon layer. This causes a negatively charged electron to be dislodged from this atom. The electron leaves behind a positively charged hole. This positively charged hole is grabbed by the p-type silicon and the front electrode, the negative electron by the n-type silicon and the rear electrode. At this moment, an electrical current starts flowing. Not all photons that strike the solar cell will knock out an electron. Photon particles have different energy levels corresponding to their color within the solar spectrum. Only half the energy of high-energy photons is used. The other half is lost as heat. Photons with low energy levels pass through the cell before they've been able to knock out electrons. Increasing the optical thickness of thin-film solar cells improves the chances of photons colliding with electrons. TU Delft studies at least 3 methods to improve the yield by means of optical thickness. The surface of the transparent front electrode is roughened using nanotechnology. The roughness of the material lengthens the path of the incoming photon, with a greater chance it will knock out an electron. A reflective layer applied to the rear electrode will reflect photons back into the cell. This gives them a second chance of striking an electron, and nanocrystals added to the reflecting layer can shoot photons back into the solar cell like a pinball table. These 3 methods improve the yield of thin-film solar cells. This is a major improvement on the first generation of thin-film solar cells. In 1974, the yield was just 2.4%. The expected yield for 2015 is 15%. Thanks to their lower cost and their flexibility, thin-film solar cells are suitable for applications on houses, office buildings, clothing and bags. Researchers at TU Delft are enhancing the yield of these solar cells to pave the way for widespread use.